In the last lecture, we finished up working with the categorical data, and we'll work with it again. But for now, we're pretty much done with that. We had made frequency distribution tables, including the frequency distribution, the relative frequency distribution, and also the percent distribution, which is really just the same as the relative frequency, just different way of presenting it. And then we made some charts, right? We made a bar chart / column chart, and then also a pie chart. Okay, so now we're going to get into some numerical data. We're going to make some tables and charts for numerical data. So it's a little bit different than what we just did, sort of. I mean, the charts are similar anyway. So as I mentioned previously, with the numerical data, we need to actually define the categories ahead of time in order to break a data set out into the different categories. So it's not going to be like the types of beer that we named, where the names are the obvious categories. Here we're going to have to define them as ranges of values. Okay, but we'll get to that in a minute. First, we're going to present it. Take a table of data and present it every data point, but in a shorter way than actually showing just the raw data set. Okay, so that's what we're going to first start with, an ordered array, which is pretty straightforward. Really, it's just sorting the data, so it's in order. And then we'll make the stem and leaf display. Then after that, we'll get back to the frequency distribution tables with the three distributions we already know how to make. Except for, again, we have to redefine categories for numerical data, and then some new types of distributions. And then we'll have some graphics. That's this last part. So let's get started. So we want to organize numerical data. So here's an example of some raw data. Maybe it's some people's ages at some meeting. Something like that. I think I have 2, 4, 6, 8, 10 observations. Okay, and then of course, first thing I want to do is order it. As I said, this is an ordered array. It's in order now. Kind of a weird thing to call it, but that's what it is. So sorted data, and then we're going to create this stem and leaf display. So this is just kind of a overview of what we're going to get into pretty quickly here. But just to point it out, and we'll get back to it in more detail, we have a stem, so that's what we have here, and then we have leaves, trailing digits. So if we look at our ordered array, we start with 21. Well, that's what it says here, 21, 24, 24, right? We're counting for every observation. So it's kind of a nice way to present at least fairly small data sets. I mean, if you have 1 million observations, obviously you can't do this, but it's nice for this, where we have 10 or even 100 isn't bad to do a stem and leaf with. Anyway, so we'll get to that in more detail later. Pretty quick, but start from the beginning. So here I have some data that is the amount due on customer accounts with a particular mail order firm that sells stuff. So they are owed this much by different customers. So this is raw data, and again, first step, depending on what you're doing with it, sort it. So hard to tell any information out of the raw data, right? Seeing the maximum, the minimum, not that hard, but it takes some searching through the data. But with the ordered array, at least we can see the maximum, $37, and the minimum, $3. Okay, and you also get, like I says, a rough idea of the frequency of the different observations. So clearly, $10 shows up the most. All right, there's 3 of those. So you could even make a frequency distribution table out of just this pretty easily without using any functions in Excel. But you don't need to do that. Okay, so next we're going to make the stem and leaf display. So quicker than I thought we would be getting here. So again, So typically you need to define the stem unit. Okay, so our example that we first had up here, this 10 observations, this is our stem, and that is the tens digit, right? So that's why it says here, stem unit is 10. Sometimes you see these where it defines the leaf unit. So the leaf units in this case would be ones, right? Here's our data. If the tens unit is what we're going by for the stem, then of course we start with 0 because some of these are less than 10. Right? So again, note that the units digit is on the left side of the bar, and it's accounting for every observation. Right? Each leaf represents a single observation. Do not use commas, and you should try to get use the same spacing for each, because as we'll see, it's we turn it on its side, you can almost visualize a histogram with a stem and leaf plot. But we'll get to that in a minute. So what about this? Again, well, you tell me, what's the minimum here? Well, same data we looked at here, right? So what's the minimum? $3, right? First leaf. This has to be in order. Okay, that's why we need the ordered array first before we ever make the stem and leaf. Okay, and then the maximum, of course, $37. Okay, and again, you can kind of see the most frequent here. We have 3 zeros, right? Maybe even a little easier than we could see here. Not much easier. So $10 most frequent. So nice way to show a whole data set, as long as it's not too big, in a nice compact way. So let's do another example with the Hudson Auto Repair data. Okay, so here we have the manager of Hudson Auto wants to have a better understanding of the cost of parts used for tune-ups. She looks at 50 customer invoices for tune-ups and collects the data. So here's the data, raw data, no ordering or anything. Hard to find any information here, right? I mean, if you search, you see the highest cost was $109. The lowest, I'm not even going to try to find it. Okay. And then, of course, we want to take that and sort it. Now we have our ordered array. So lowest cost, $52, highest, $109. So I got that one right anyway. Most frequent, kind of hard to tell easily, right? There are several 62s in here, that might be it. But let's make a stem and leaf display. So here's our ordered array, our ordered data set, and here's the stem and leaf display. So fairly straightforward. So clearly the tens digit is again the stem. So we start with $52, $57, $62, there's 4 observations, etc. Remember, you got to account for every observation in the data set in a stem and leaf display. And you also need to define the stem. I guess I didn't put it on the slide, but it's obviously the tens digit again. So the stem is 10, or the leaf is 1. The ones, the units, the ones digit, unit digit. Yeah, tens, ones, whatever. Okay, so this kind of gives you an idea of the distribution of the data too, right? I didn't mention that before, but here, what do we have? Most observations are between $60 and $80, or well, maybe that's not most. But those are the most frequent outcomes are in the $60s and $70 range, right? Only a couple below $60, just the 2. And over $80, quite a few. So that's what you can kind of see just thinking about this like a bar chart, right? Horizontal bar chart. As long as the spacing's the same between each number, you can visualize it that way. You get an idea of how the data spreads out and what the most frequent range is. Okay, so I'm getting you ready for our distribution tables. where we'll actually make our histograms from that. Okay. So some other points about the stem and leaf display. If we have decimal data like this, so how do we do that? Well, this is just one example. We could use the units digit as the stem, and here I defined it as the leaf unit is a tenth. All right, so that means you read this as 8.6, 8.8, 9.1, etc. And the max is 11.7. Now we could do this as a units digit, right? Doesn't sound like fun, but I'll just do it for fun here. So what do we have? Units digit, we would have 0, well, no, it would be just 0 and 1, right? I mean the tens digit, sorry about that. This is the ones digit is the stem. So what if I use the tens digit? It's not a very good stem and leaf display because I only have two stems then, right? Here, let me make this a little bigger. Okay, we'll make this a nice bar. So what do I have? I'd have 0, 8. Okay, now we have a problem. We can't put 8, 6 because that's not correct. So we actually have to lop off the trailing decimal point. So there's a couple different ways you could do this. Oftentimes it's just truncated, so it's not rounded, it's truncated, which just means cut that off. Okay, so we'd have what? 8, 6. What am I doing? No. Sorry. 8, 8, 9, 9. That would be it, right? Lopping off the decimal points. So the leaves are just the units digit. And then we would have 10. Oops. Dang it. 11, 11. Right? So we've accounted for all observations. So anyway, my point is this is not really a good stem and leaf display. You don't get a good idea of the spread of the data. We had to lop off the decimal points so we don't have as much detail. So this one is much better, right? This one that's on the slide. Yeah, so we'll leave it at that. Okay, hopefully that makes some sense. So you do have choices to make, but you know, the idea is you make the best stem and leaf display you can that gets across the most information. Now what if we have more than one decimal place? No, we don't have that yet. Another example. So here's a bunch more observations. 135 mutual funds and their one year rate of return. Okay, so this is an ordered array, and we see we range from a 10% return up to a 38.1%. So I wish I owned this one. Even the 10% isn't bad in today's environment. But you can see that's much lower than the rest. So I'm going to make this into a stem and leaf and point out some more things you have to pay attention to when you create one of these tables or diagrams. Okay, so here's the stem and leaf. So this time I used the tens digit again for the stem, or sorry, the units digit for the stem. See, I guess I should read my slide. It's the units digit, so the first one is the 10, 11. If it was the tens digit, this would have to be moved over, so it wouldn't be as nice. Well, I mean, it would change the display, of course. But in this case, you know, it makes sense to use the units digit. I mean, they go up pretty nicely. So note what I have here. I've got a leaf here, which is a decimal place, right? A tenth. These are tenths of a percent. There are no leaves here. That's because we don't have any data in this range. But I still have to show them. You can't just go 10, 17. That's not an appropriate stem and leaf diagram. Okay. So then there's the next one, and then a gap again. There's no 18 point anything, so no data there. Oh, oops. Stop that. So, like I said earlier, if we turn this on its side, you kind of get an idea of the distribution, right? So obviously the center of the distribution is here. Most of the returns, the most frequent returns are in the 30%, 30 point something percent, right? 30 to 39%. Okay, then it kind of spreads out sort of evenly in both directions. Not really. I mean, obviously there's more to the left, so and some very small ones. So this you could call stuff we'll get to more later, but this is kind of an outlier, right? The main body of the data is here, and this one's way down below. So we might call that an outlier. Now later we'll have tests for that. We're not going to worry about it too much, but you should know what it is. 7 or the 17.7, not really an outlier because it's, there's some other ones close to it. It is in the tail. So later when we look at shapes of distributions, this would actually be a skewed distribution that's pulling to the left, right? We have more spread to the left than we do to the right. So you can get a lot out of this. And like I said before, if the spacing is the same between all the numbers, and it is here, if you envision these as bars, it's a histogram or a bar chart, right? Vertical bar chart. Okay. So most frequent observation, still kind of hard to see, but it looks like it might be this 30.5%. I don't know if that's the case. Yeah, it seems to be that though. So any questions? Well, if you have any, please post them to the D2L discussion room. Okay, some more information. If we have big data values like this in the thousands, okay, so look at this stem and leaf display. So I went with the tens unit. For the leaf. The leaves are the tens unit. So it's kind of what I did earlier with the decimal data. I lopped off the decimal, right? And that's what's happening here. It's being truncated. So this is 168 here. Or since the leaf unit is 10, we need to add a 0 to each of these when we read it. So this is 1,680. Right? That's this value. I lopped off the 2, so we lose some information when you have that. I mean, we could have made this stems unit in thousands and we'd get a different table. So you can try that, see what the table looks like. It might be all right. I mean, still have. Well, then you'd have to lop off even more, right? So anyway, so different ways of dealing with it. So what I already said. So truncated, rounded down. Of course, then even this 1,717, this is rounded down to a 1, or 1710, right? So kind of weird to truncate things instead of rounding, because we would think, oh, you round this, it's actually 1720, but nope, don't typically do that in stem and leaf displays. You don't need to worry about it. I won't give you any like that. So as I said earlier, if we have relatively small data sets, stem and leaf displays pretty nice, because you kind of get the distribution shape of the data too. However, also as pointed out, difficult to use for large data sets, data with many digits, because we lose information. If we have a very large range but few observations spread over it, then we'd have, a lot of areas like this. That wouldn't be too good. So let's come up with some other ways to present large data sets. Okay, and that will be our frequency distribution tables and histograms, etc. So first a quiz. So you should do this. rawbeerdata.xls. So get the one with the templates in the folder. Same one we started with yesterday here. Looks like this. In the topic 1 and 2 folder, whatever it's called. So we have the raw beer data with templates. Looks like this. Okay, so do the stem and leaf diagram here and upload it to the Dropbox. You have till midnight. Okay. And then we'll come back. This will be a later quiz. Actually, might as well wait till we complete everything, and then you can upload it to the Dropbox. Okay. So go ahead and make that stem and leaf diagram, and I'll stop the video here.